evaluate these four definite integrals using U-substitution. So the first one is the integral from 1 to 2 x times the square root of x minus 1 dx. So we have a linear function x minus 1 inside the square root, so we definitely let u be that x minus 1 du equals to just a 1 dx. That creates a problem in here, because if you do this, this becomes a u, right? So this becomes a u, so there is no way to get rid of the x outside of the square, that is outside of the square root. So therefore we have to rewrite the u in terms of x. So that is u plus 1 equals to x, right? So that means x is equals to u plus 1. So let's keep that in there for now. And then put the 1 and 2 in terms of u, because if you look at this problem, that is supposed to be x equals to 1 to x equals to 2, but people don't write the x equal in there. So u of 2, that is equals to 2 minus 1 equals to 1. U of 1, that is 1 minus 1 equals to 0. So in this integral gives me u equals to 0, u equals to 1. So the x outside of the integral is now this, u plus 1. And then the square root is a square root, the x minus 1 is a u, and then du. So there will be no more x right here. And then from 0 to 1, so this is u to the 1/2. So we have u to the 1/2 times u to the first. 1/2 plus 1 is equals to 3 over 2. And then plus u to the 1/2 du. Okay, and then simple power rule, plus 1, 5 over 2, reciprocal 2 over 5. Half plus 1, 3 over 2, reciprocal 2 over 3, such that u goes from 0 to 1, plug in the 1, so 2 over 5, then that will be 1 to the 5 over 2, plus to the 1 to the 3/2, easy number, and then once you plug in the 0, everything becomes 0, right? Minus 2 over 5, 0 to the 5 over 2, plus 2 over 3, 0 to the 3 over 2. Although the entire thing is 0, I will write it anyway. So the result is 2 over 5 plus 2 over 3. So the answer is equals to 16 over 15. And then that's it. That is the answer to the first problem. Let's move on to the next one. So the next one we have ln. So let's do that. Is e to the 4th 1 divided by x times the square root of ln x dx. Okay, so since we have ln inside the square root function, I'm going to let u be ln x. So du is equals to 1 over x dx, and then x du is equals to dx. So that is enough to get rid of the x in the denominator once you do the change of variable right there. Okay, so let's change the e and e to the 4th. So we have u of e to the 4th, that is ln e to the 4th. Still remember this. So this one you can use the power rule of ln. So all you have to do is you bring the 4 to the front. So that is just equals to 4. Where is the ln e? Ln e is equals to 1. Alright, so u of e, that is just ln e, which is equals to 1. And then the integral becomes u equals to 1, u equals to 4, 1 divided by x, and then the square root of u, and then we have x du, and then the x will be cancelled, so cancel, and then you have integral from 1 to 4, u to the negative 1/2 du. So this is a simple power rule. Add 1 to the negative 1/2, you have a positive 1/2, reciprocal is 2 from 1 to 4. So this is 2 times the square root of 4 minus 2 times the square root of 1. This is called the fundamental theorem of calculus. That is 2 times 2 right here. So 2 times 2 is 4 minus 2. The answer is equals to 2. So that is the answer to the second integral. So let's do the next one. So the next one we have a ez, right? So on top we have the green one. We have a ez plus 1, and then the integral we have a e to the z plus c. let's write this down first. So we have the integral from 0 to 1, e to the z plus 1 divided by e to the z plus z, and then dz. Okay, should I let the u be top or bottom? The answer is you should let the u be the bottom, ec plus c, because once you take the derivative of that, you have e to the z plus 1. That is enough to get rid of the numerator, dz. And then 1 divided by ez plus 1 du, that is equals to dz. The derivative of ez is equals to itself. The integral of ez is equals to itself. And then change the x equals to 1 and x equals to 0. So u of 1, then you have e to the 1 plus 1. That is e to the 1 plus 1. You don't need to approximate. And then u of 0, that is equals to e to the 0 plus 0. What is e to the 0 equal to? E to the 0 is equals to 1, right? 1 plus 0 is equals to 1. All right, then you have integral u equals to 1, u equals to e plus 1, and then the integrand, you have a ez plus 1 divided by u, and then 1 over ez plus 1 du. So how do I get these big things right here? I already replaced this to here. That gives me this piece. All right, so the dz is now the entire piece right here. And then get rid of the z, get rid of the z, so there is no more z. And we are ready to roll. So we have integral. I will just use the equal sign, right? Equal. And then from e plus 1 to 1, and then we have 1 over u du. Should I apply the power rule? The answer is no. When you do integrate of 1 over x or 1 over u, that is just ln. So this is ln, absolute value of u, and then such that u goes from 1 to e plus 1. Is the absolute value optional? The answer is no. You don't need the absolute value unless you can prove the quantity of u is positive. For example, here you have ln e plus 1. You can just use a parenthesis because e plus 1 is always positive. E is about 2.7. 2.7 itself is already positive. You add 1 to it, 3.7 is always positive. So it is okay to get rid of the absolute value. And then ln1, you don't even need to worry about it because ln1 is, what is that equal to? ln1 is equals to 0. And then this, you can simplify this answer. Oh, this is equals to 0, right? This is equals to 0. Then the whole thing is ln e plus 1. That's it. You do not need to approximate the answer. And there is no other way to rewrite this. Okay, you do not need to approximate this answer. Just leave that as ln e plus 1. All right, let's do the last one. So the last one we have the integral from 0 to 1, 1 divided by 1 plus the square root of x raised to the 4th power dx. Then obviously the u is 1 plus square root of x. Then du is equals to, bring the 1/2 down, x to the negative 1/2, right? dx. And then you have du equals to 1 divided by 2 root x dx, right? Or you can just, or let's just use the 1/2 power. So let's just keep the 1/2 power. And then bring that to the other side, 2x raised to the 1/2, and then du equals to dx. And then we are ready to place this thing over here. What's the problem? The problem is that it's not going to get rid of anything. And then you have 1 divided by u to the 4th power. So that creates a problem. Let's see how we deal with the problems right there. Okay, let's handle the x equals to 1 and x equals to 0. So u of 1, that is 1 plus the square root of 1, that is equals to 2. And then u of 0, that is 1 plus root 0, that is equals to 1. But the thing is, look, I should just do this in red. You have the integral from 1 to 2, right? I should say u equals to 2, u equals to 1. You have 1 divided by u to the 4th power. And then you do the change of variable. You have 2 times x to 1/2 and then du. But the problem is there is no way to get rid of this. No way. Then that means you have to rewrite the u. So that tells me now is the time to rewrite this. So we have u equals to 1 plus the square root of x. That means the square root of x is equals to u minus 1, and then we can bring the u minus 1 over here. So the entire integrand is in terms of u. Alright, so let's continue. So now we are doing the right thing. So we have integral u equals to 1, u equals to 2, 1 divided by u to the 4th times 2, and then we have a u minus 1 right here, and then that is du. Alright, we got a lot of work to do. And then we have 1 to 2. So we have 2, let's bring the 2 out. And then we have u minus 1 divided by u to the 4th du. And then this, we have to break this down into 2 fractions, and then we use the simple power rule. So 2, 1, 2, and then u divided by u to the 4th du minus 2, 1 to 2, 1 divided by u to the 4th du. Okay, just like this. Look. You have 5 minus 1 over 4, right? That is 5 over 4 minus 1 over 4. That's how we split that up. Or if you have 2 times 5 minus 1 over 4, then you have 2 times 5 over 4 minus 2 times 1 over 4. Just a little distribution. Okay, 2, 1, 2, u to the negative 3, 2, 1, 2, u to the negative 4, du. Simple power rule. So we have 2. This is a plus 1. 1 divided by that. Plus 1. 1 divided by that. Okay. So we have a negative 1. So we have a negative 1. And then using the fundamental theorem of calculus, looks like we will have to deal with 1 over 2 square, right? Minus 1 over 1 square. And then plus 2 over 3. And then we have 1 divided by 2 to the third minus 1 divided by 2 to the 1 to the third. Okay, let's see. Then negative 1 over 4 plus 1 minus 2/3 times that. So this will be 8. 8, then that will divided by 2 is 4. So that this is a 12. And then minus 2/3. So this one, if you get all the math done, so let's take a look at what that equals to. We get a common denominator, 12. So this is a negative 3, right? And then plus 12 minus 1, and then minus 8. So we have negative 11, 3 minus 8. We have, looks like we have 12 minus 12 right there. So that means that is equals to 0. That gives me a 0. I'm not sure if I make some mistakes right here because on my notes I have a 1 over 6. So let's go over this one more time. Let's see. Let's start checking this from, let's use another color. Let's start checking this from the integration. So the integration starting from this line. So 2 minus plus 1, okay, so this is correct. Plus 1 reciprocal. So this line is good. And then we have a negative 1. 1 divided by 2 square. And then 1 over 1 square, okay, minus minus, so this minus minus, we get a plus 2/3, 1 over 2 to the third, and then 1 over 1 to the third, okay. So negative 1 over 4 minus minus to get a plus 1 over 1. And then 2 over 3, and then this is 1 over 8, so you have 1 over 12. Oh, this is a plus, so this is a plus right here. This is a plus. And then plus minus, that gives me a minus, so plus plus, that gives me a plus, plus minus, that gives me a minus. Okay, so 2/3, all right. And then the common denominator is 12, so you have negative 3 plus, then this will be a plus 12, then this will be a plus 1 then. Then you have a 13, 10 minus 8, then you have a 2 over 12, that will be equals to 1 over 6. So the one on my notes, this is correct, this is correct, this is supposed to be 1 over 6. All right, just fix this one for you. Okay, and that is also the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help and support to the channel. As always, see you all in the next one. Signing off for now.